Hey everyone. So we are moving forward with our module 6. This is already a pretty long module to begin with, just because there's so much within trigonometry, but we have cut it down a lot. As you saw, we kind of skipped around in the mod 6 part 1, and we're going to be doing the same thing here. So we're not going to be covering 6.6. I'm going to jump straight ahead to 6.7. So if you guys want to follow along, that's what we're going to be doing today. So this is a review of 6.5 that we learned last week. So just graphing sine and cosine. Grab a pen. So just to kind of write just the basic formula here and to remind you. So this is just the generic formula, right? And if you guys don't see a number in front of sine, that means that it's just a 1. But if you do see a number in front of sine, then that number is equal to the amplitude. So if you don't see a number, then the amplitude is just equal to 1, right? So that's the amplitude, which, to remind you, is the amplitude is the distance from the midline to the peak and from the midline to the valley, right? So it's how high and how low your sine or cosine graph goes, right? So then we have our B value, which helps us find our period. And the period for sine starts on the midline, it goes up, crosses through the midline, goes down, and comes back to the midline. So this is one full sine wave. And then if you remember cosine, looks like this and is like that smiley face. So that's one full period for cosine. So to find the period, the length of the period, you take 2 pi and you divide it by that B value. So again, if you don't see a number in front of X, that means that B is just 1, which means the period size is 2 pi. So from start to finish, 1 full period is equal to 2 pi. But if this is a number, then that means that your period's either getting smaller than 2 pi or bigger than 2 pi. So that's how you find the period. That's what that B value is. And then finally the C value. So anytime you see a plus or a minus, like separate from the sine or the cosine function, that's your midline. And if there's nothing added or subtracted from it, then your midline is 0, which is the x-axis. But if you do have a number, the midline is your vertical shift, right, away from the x-axis. So how high is this graph going up or down, as is? So that's everything that we learned last week. This week, we are going to be introduced into what we call a phase shift. So the midline is a vertical shift and a phase shift is a horizontal shift. So we're going to see what that looks like. The way that we write it is actually extremely similar to quadratics or parabolas. So if we think about a quadratic, this is like the generic formula for a quadratic, right? So this plus k is your vertical shift in a quadratic, just like the plus c is. This a value tells you how like narrow or wide your parabola is. I guess in a way it tells you how narrow or wide the peaks and valleys are. It's kind of like the B value, I guess, too. I don't know. But this guy right here represents a horizontal shift. So notice how it's within parentheses and being subtracted or added to the X. So we're actually going to see something extremely similar to this type of writing on the following page. So you guys, whenever you see parentheses and you'll see X minus H or X plus H, that's what this means. It's a horizontal shift. We just call it a phase shift. And just like with quadratics and all other functions, if it's a subtraction, it's moving to the right. And if it's a plus, it's moving to the left. So that has not changed in all functions. That's actually the same. So you'll see it here written like, so there'll still be the B, there'll still be the A, there'll still be the C, but we'll have parentheses and it'll be X minus H, like that. Okay. So just in case you guys have forgotten, let's just do a quick little warm up to make sure that we feel pretty solid about these graphs. So let's go ahead and try number one. If you guys want to pause the video, you're welcome to, just to kind of get even more practice. If you feel like you're solid on these, you can skip ahead, or you can just follow along. But if you want to pause, go ahead and do so now, because we're going to do this kind of quickly now together. So I personally like to draw my midline first. So that's at -1. So that's where the graph shifted, right? It's a vertical shift. And then my period is the B value. So there's nothing there. So that's a 1. So this means my period is 2 pi over 1, which is just 2 pi. So that's where my full period will finish for sine. So it always starts on the y-axis and the midline right there. And then it'll finish on the midline and wherever my period ends, which is at 2 pi. So on the following page, when we introduce the phase shift, you guys are actually going to find that your graphs don't always start, the periods don't always start on the y-axis because they have shifted left or right. We're not there yet, so let's just remember. So it starts here, ends here. And then to help us start to build this, I like to do the halfway method. So I count exactly halfway, which is at pi, and I'm going to place a dot on my midline. Then I find the 2 quarter points. I go halfway, place, halfway, place, and now this is in quarters. I'm going to have 5 points total. I have 3 right now, start, finish, middle. So then this quarter point, this is where I introduce my amplitude. So my amplitude is 2. So that means that it's 2 units above the midline, not the x-axis. So from the midline and at this quarter point, we're going to go up 2 units. And then you're going to do the same thing at this quarter point, except you're going to shift down 2 units. Like so. And then we connect those 5 points. And there is 1 full period of this sine function. Okay, so then let's do a reminder with cosine as well. So same thing, I like to start at my midline, which is 2. All right, then I like to skip ahead to the period to figure out where it starts and begins. So the B value is 4. So for the period, we do 2 pi divided by B. And then we simplify that. So 2/4 is 1/2 pi over 2. So this is going to be my finisher. So the start of cosine starts on the y-axis, and then it's going to finish at pi over 2. So this is going to be really small, right? To remind you, the cosine graph does not start on the midline like the sine does. It starts above the midline, unless, of course, it's negative, then it's a frown, right? So on the y-axis, from the midline, we are going to start above the midline, and we're going to go up however much the amplitude is, which in this case, there's an invisible 1 here. So that's my amplitude. So from the midline on the y-axis, I'm going to go up 1 unit, and that's the start of my smile. It's the left corner. It's going to U down and then come back up and finish also above at the pi over 2. So at pi over 2 mark from the midline, I'm going to go up 1 unit. So those are my two ends of the smile. So then where does the smile dip below? Exactly halfway. So I do like the 2 points halfway, which is there. And I'm going to go down 1 unit this time. Then we find our quarter points. Just like with sine, we're going to have 5 points. And so here's a quarter point and here's a quarter point. And the quarter points for cosine lie on the midline. So there are my 5 points. And then my graph for this function looks like that. So that was hopefully a good little review and reminder of sine and cosine graphs. Okay. So it's really important that you guys have a solid understanding of how to graph just a sine and cosine graph with an amplitude, period, and midline shift, because from there, we're going to introduce the phase shift, the horizontal shift. Okay. So let's go to the next page. This is kind of a good overview. I already talked about this on the previous page, but if you guys want to read through this, you can. So like I said, everything is the same. We still have A, B, and C. We've just introduced this phase shift, which is a horizontal shift. And if it's a minus, it goes to the right. And if it's a plus, it goes to the left, just like with all other functions we've seen here. So what I personally like to do is I like to graph my parent first, meaning I like to graph kind of like what we just did on the previous page. I like to graph my sines and cosines with my amplitude, whatever my period is, and whatever my midline is. I like to graph all of that first, and then I like to move it to the left or the right, however much. So for my keys, and today you guys are actually going to see 2 graphs on one. You are not required to graph the parent. Some people are able to see this shift and everything else in their head and just boom, graph it. For me personally, I need a visual representation. So I like to graph what I'm comfortable with first, which is A, B, and C, graph it like I've been, and then I like to move that whole graph left or right, depending on whatever the H value is. So that's how I'm going to be doing it. But if you are able to jump straight into the one single graph with A, B, C, and H, go for it. Okay. So that's a good little overview for you guys. So let's get started. So we'll do this one together. Okay. All right, so first thing to identify, this is a sine graph, not a cosine. There's no midline, which means my midline is the x-axis. I still personally like to draw it. You don't have to. You don't even have to draw the midline at all. I just like it as my guidance. All right, next up, what is my, let's do period. So my period is 2 pi divided by whatever the b value is, which is always going to be in front of the x. So there's an invisible 1 here, so that means my b value is a 1, which makes my period at standard 2 pi. Okay. I am going to be drawing maybe these 2 colors. So I'm going to draw my parent in this gold color. Okay. And then my shift in green. So I do too. Sometimes I'll do parent in pencil and then the shift in pen if that's how you guys want to do it. If you only have one color or one pencil, whatever, you can do the parent as a dashed curve and then the shift as a solid. That would be a great way to identify the difference between the two. Whatever you choose. And again, you don't have to do the parent. You can go straight into whatever this function is. So I'm going to be doing the parent first, which means I'm essentially going to be erasing the shift. All right, so I'm not there yet. So I have my midline at 0. I know my period's 2 pi, so that means I'm starting on the y-axis in the midline, and I'm ending at 2 pi in the midline because my period is 2 pi. So start to finish, that's where it ends. Then I'm going to do my halfway method, count halfway, plot a point, done. Count halfway, mark, count halfway, mark. I got my quarter points. And how far am I going to go up or down? That's based upon the amplitude, which is 4. So at pi over 2 from the midline, I'm going to go up 4 units. And from the midline at this 3 pi over 2, I'm going to go down 4 units. There are my 5 points. That is enough. So let's go ahead and connect. There it is. So usually with shifts, sometimes it's easier to draw the full grid. So I'm going to go ahead and do that. So at pi over 2, it's going to go down 4. At pi, it's on the midline. At 2 pi, it's on the midline. And at 3 pi over 2, I'm going up 4. And then connect those 5 points. And there it is, 2 full periods, okay? So again, this is my A, B, and C, no phase shift yet. So now I'm gonna pick up my green pen, and all I'm gonna do is take all of these points and move them. What do you think minus pi over 4 means to you? So it's a horizontal shift to the right by pi over 4, okay? So I'm going to be moving all of these points to the right by pi over 4. Well, how many units is pi over 4? Well, pi over 4 is half of pi over 2, right? So if pi over 2 is 6 boxes, then how many boxes is pi over 4? It's 3 boxes. So I'm going to be moving every single point to the right 3 boxes. So usually I'll kind of figure it out in terms of boxes. It just makes things a little easier. Okay. So this guy moves right pi over 4. 1, 2, 3. 1, 2, 3. 1, 2. This guy comes off. I mean, you're welcome to still put it there so that you can kind of guide yourself. Just fine. This guy, 1, 2, 3. 1, 2, 3. 1, 2, 3. Like literally every single point is moving to the right by pi over 4. And then now I have my new points, and I'm going to connect those guys. And now you're able to visually see that phase shift. So my graph moved to the right by pi over 4, or 45 degrees. So you can leave it like this because the graph doesn't expand. That's totally fine if you didn't put a point here. If you did put a point there, I don't care, bring it up. Same thing over here. You're welcome to kind of drag it down. You at least have that idea of where is it going. And that's it. That's how you do phase shifts. Not too bad, right? Hopefully. All right. I want to see if you can pause the video and handle number 2. So go ahead and pause it, and then I will be walking you through this. So if you get stuck or this is difficult for you, go ahead and keep watching, but at least attempt it. So try and pause the video right now, and then we'll go over it. Okay. So we can start with the midline, which is up 3. Your midline should have been here. Ooh. It's pretty sloppy. This time around, it was a cosine graph, so I hope you started above the midline instead of on the midline like a sine graph. And then our period is 2 pi over 4, which reduces to pi over 2. So that's how big the period is, okay? Our amplitude is this number here. It's a 1, so that means that our cosine smile is going to be 1 unit above or 1 unit below the midline. So once again, I'm going to do the same thing and plot my cosine with A, B, and C before the shift first. Then I'm going to shift it, which my shift, this plus pi over 3 means that it's going left pi over 3. Okay. But let's draw without the shift first. So this is cosine. It starts 1 unit above the midline on the y-axis, and then it ends at pi over 2, 1 unit above. Then we count halfway and go 1 unit below, and then my quarter points. So that is 1 full period of my cosine graph before the phase shift. I'm going to do a couple more periods just, and make sure you guys are actually plotting the points. Don't be sloppy and just freehand it. That's not going to get you far if you move on after this course. Okay, and then maybe because we're going left, it might be nice to see some over here. Okay, I think that's enough. 4 full periods. Cool. So after we have that, now we can move to the left by pi over 3. Let's talk about how many boxes is pi over 3. A good trick that I have is how many boxes is pi equal to? 6 and 6. Pi is equal to 12 boxes, right? So if I want pi over 2, I literally take whatever pi is equal to, 12, and I divide it by 2. So pi over 2 is 6 boxes. So how many boxes is pi over 3 going to be? Well, pi is 12 boxes, and I want to divide that by 3. So pi over 3 is 4 boxes. Sorry, easy as that. So just always take whatever your pi is, however many boxes, and divide it by whatever you're trying to get. So we are going to move to the left, pi over 3, aka 4 boxes. So we're going to take all these points and move to the left. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. And there's 1 full period of our phase shift graph. So I'll do a couple more just so that you guys can see. My dog Jax is currently passed out at my feet and snoring. Cool. It's kind of a pretty picture when you guys draw the parent too, but you don't have to draw the parent. If you didn't draw the parent, you should be looking at this maroon colored graph if you did it correctly. All right. Cool. So let's try a couple more. I want you guys to kind of see how this grid looks much different than this one. So this one's in terms of pi. This one's in terms of units, numbers. So what's going on here? Well, let's see if you can figure it out. First of all, notice how my phase shift is by a unit instead of like pi over 3, like it was on the previous page. Also notice our B value is not a whole number. It's not 1, 2, 3, 4. It's pi. So what happens when we find the period? Let's take a look together. So again, to find the period has not changed for sine or cosine. We just do 2 pi over the b. And what's your b in this case? Pi. So if I do 2 pi over pi, what happens? Cancels. What's my period? No longer in terms of pi. So we have always been used to our period being in terms of pi. Now it's not, it's in terms of numbers. And that's why you guys see numbers down here instead of pies. Okay? So that's the only difference. Let's still graph it. If you guys want a challenge, little challenge, go ahead and pause the video and try doing this one on your own. If not, we'll see how it goes. Okay. So I'm going to start with my midline, vertical shift up 2. There she is. What's next? This is a sine graph, so it starts on the midline and the y-axis, and it'll end at my period of 2 units on the midline. Right? My new midline is not here. Okay. Same stuff. Count halfway, plot a point, count halfway. That's our quarter marker, halfway, quarter marker. At the quarter markers, I'm going to go up 3 units. 1, 2, 3. And here. 2, 3. Like that. So there's my graph before the shift. Now let's see what it looks like after a phase shift. And if there's this x minus 1 here, what does that mean? Where am I going? To the right by 1 unit. So if you guys notice, 1 full unit on this scale on the x-axis is 4 boxes. So all of these points are going to move over 4 boxes. And that's what 1 full period looks like. So I hope this wasn't too tough because we've already spent some time on just regular sine and cosine graphs. We just added in a phase shift. So not too complicated. If you guys want one more practice, this is the last of our classwork. You can go ahead and do this. Pause the video because I'm not going to explain it. I'm just going to pop up the answer for you. So if you don't want to pause the video and try the problem, that's okay. You get practice on homework, which I'll announce after I do this problem. So go ahead and pause if you want to do it now. Okay, so here's just some of my notes. So the period is 1, the phase shift was right by a half, and then this is a cosine graph, so I hope you didn't forget about that. The gold color is my parent, and then the purple maroonish color is my phase shift. So if you guys just did the phase shift, make sure that it doesn't start 1 unit above on the y-axis with the shift, because this point went here, it actually starts below. So it looks like that. Cool. All right. Well, to get into homework, so the packet for this is posted in the same location as the other RSG packet. So it's still at the bottom of the Mod 6 topic on Google Classroom. It's just called Mod 6 Part 2 RSG. But this one will be called, this is still 6.7, still matches, and you're only going to do numbers 1, 4, 6, 7, 9, and 10 for homework from 6.7. Okay? All right, guys, have a good one.